example, show the remainder theorem for an arbitrary theorem second degree polynomial function f of x is equal to ax squared plus bx plus c by using algebraic manipulation. Let's divide the function f of x by x minus r. So if we have this, we can divide f of x. Let's divide it by x minus r. F of x divided by x minus r. And this can be equal. So I'm writing the second part here, which is f of x is happen to be ax squared plus bx plus c. And everything here is divided by x minus r. Okay. So now if I add into an expression 0, still it is going to hold because I am applying here property of identity of addition. If I add in a 0 to anything, to an expression, still is going to hold. So now here I am writing ax squared, okay, and I'm adding a 0, plus a 0. But instead of plus 0, I am adding here minus arx, okay, plus arx, which is a 0. Practically, this is a 0, arx. Because minus arx plus arx is 0. And I am writing the remaining, plus bx plus c. Plus bx plus c. So I have right to do this. Plus bx plus c. Everything divided by x minus r. X minus r. So let me write again 1. But here I am taking just this part. Ax squared minus irx. Here is GCF. I can find the ax. If I write here ax, okay. And if I'm taking as a GCF of the first two terms here, what is going to remain inside is going to remain the x minus r. X minus r. And everything here divided by x minus r. And the second part, which I'm writing plus, and the second part is, what remains here is arx plus bx plus c. So arx plus bx plus c plus bx plus c. And now what I am doing here is divide by x minus r. But in the first part, x minus r with the x minus r goes away. So this is going to be equal. So f of x divided by x minus r is going to be equal with the ax. Ax is the first part, and the second part here, I am going again to add a 0. Let me write a big line here. And I'm writing arx plus bx. So arx plus bx and I'm writing here minus let me write here AR plus B time R. Okay, let me add a little bit further. And here is divided by x minus r. And let me write, and what remains here remains, I wrote these two parts, arx plus bx, but plus c is a plus c here. I'm sorry, and is a plus, I didn't write the other part, is a plus a, let me write here, r because I needed to make a 0, plus b time r plus c. Plus c is, this is c here, what is remaining, plus c. And now I'm looking, if we are looking here closely, minus AR plus B time R plus AR plus B time R is a 0. They can cancel. So 0 I can add here and still is going to hold. So now what is going to be here, just this part if I'm paying attention, AX. So I'm looking to find the GCF for this part here and this part. And if I'm finding the GCF for both of them, let me write here x minus r. So, and the GCF is going to be equal to the AR plus B. So here is AR plus B. So GCF. And what remains inside here? This is plus B, okay. And inside remains x minus r. If I'm factoring, here is another, here is x minus r. And the other part, what remains here, remains AR plus B time R. But let me multiply everything by R. Let me distribute this R, which is going to be AR squared plus BR plus C. Everything divided by x minus R. X minus r. So now this x minus r simplifies. And what remains here, remains, let me write here f of x divided by x minus r, because I don't want to forget what we wrote in beginning, which is, here I didn't write, but everywhere I can write f of x divided by r, but just to not spend a lot of time rewriting this division, what I have here. What we have here is AX is a plus, what remains here, AR plus B, AR plus B, and remains this AR plus BR divided by x minus r. Okay, is AR squared plus BR plus C divided by x minus r. What I'm doing here now, I am going to multiply everything by x minus r. If we are multiplying everything by x minus r, then we are going to get the following. So x minus r, if I am multiplying here by x minus r, is going to cancel, to simplify. So here remains just f of x. And if I am multiplying here this expression, whole expression here, by x minus r, is going to be x minus r time all this expression ax plus ar plus b plus is going to be ar squared plus br plus c. But don't forget that this is AR squared plus BR plus C is, if I multiply by x minus r, is going to cancel, and here is going to remain AR squared plus BR plus C. But AR squared plus BR plus C is a remainder. Let us write the remainder here. Let me write with a different color, okay? Let me write with something what I didn't use here, the blue color, okay? So the remainder R is going to be equal with the AR squared plus BR plus C, plus BR plus C. And let me reframe this big. Let me frame here. And finally, f of x, so this is a proof, so the f of x, finally this is a proof, the remainder theorem, which is equal to the x minus r x minus r times ax plus ar plus b, and plus the remainder r. So we already prove it.